Welcome to July at Empirical's SDA Learning Center. In the last video, I demonstrated how to use the SDS Add Circuit tool to speed up designs using AutoCAD Electrical. Now I want to go back to the most basic element of AutoCAD Electrical and talk about symbol creation. The first thing that typically happens when converting to AutoCAD Electrical is to build out a symbol library. AutoCAD Electrical's Symbol Builder is a fantastic tool to use when you first start out. But unless you've customized the Symbol Builder attribute templates beforehand, you're starting with the basic install and you're creating your own attribute templates as you go. Once you create a few symbols and discover that you can reuse attribute templates you've already arranged and pre-filled, you could use those to create different symbols across the same symbol family. And you could simply use basic AutoCAD commands to quickly build out the rest of your library. As you build out one-line symbols, for example, you'll probably want to reuse the same attribute templates for the three-line symbol counterparts. Just copy your AutoCAD geometry to a new drawing, copy your attribute template from your one line, add a few more connection points, and save the drawing. You'll save time as well. In this video, I'll demonstrate the creation of a three-line transformer schematic symbol using a one-line transformer symbol template and basic AutoCAD commands. This is a one-line transformer symbol that I want to use as an attribute template to create the associated three-line transformer schematic symbol. The data shown on the one-line symbol is AutoCAD Electrical rating attribute data that was taken directly from the transformer nameplate drawing from the vendor. If I look at the symbol, the prompts of the rating attributes are filled in with the nameplate information to aid users in identifying which data goes to which attributes. It's best practice to use the same attribute templates between symbol types because they'll share their data and the prompts help to create uniform data entry. To begin, I'll copy the geometry of the three-line schematic symbol and paste it into the new drawing. I won't copy the CT terminals, things like that, because they are separate symbols, so it's just going to be the transformer, bushing terminals, and connected lines. I'll do a copy with base point and select anywhere on the symbol. Then I'll open up the new drawing and paste it anywhere in the new drawing. Then I'll go over to the one-line symbol drawing and I'll copy that and paste that into the new drawing as well, maybe off to the right. Once that's in, I'm going to explode it. I'll fix the attributes here so that they'll have the correct justification and position when I'm ready to move them over to the new symbol. Now I want to reposition my geometry so that my insertion point is at the 0,0 origin point, and then work outward from there to arrange the geometry so that the connection point attributes will fall on snap points on my grid. Reworking the symbol geometry is always the most time-consuming part of a symbol build, with or without the AutoCAD Electrical Symbol Builder. Using a grid spacing and snap points is not a requirement in symbol building. You can simply place geometry into the new drawing, decide on an insertion point, and place attributes how you would place them. Our symbol building standard requires the connection point attributes to be on grid snap points. Our grid settings is a 1/4 inch with a snap setting of a 1/16 of an inch. For symbols like this, I'll usually draw construction lines to find the midpoint of the symbol and to ascertain whether elements of the geometry are collinear. This will be important when placing connection point attributes later. I'll move the secondary winding. You can see that's not in line, so I'll move that down because the connection point is going to be on that line. Then I'll grab the rest of the geometry of the symbol and use that midpoint of the construction line I created as the base point and move the entire symbol to the origin point, the 0, 0 of the drawing. Now that I have my insertion point fixed, I can start working outward from there, rearranging the geometry so that the connection point attributes fall on a grid snap. Now that the main geometry has been placed on the grid, I'll go ahead and begin placing attributes. I'll start with this group of rating attributes and place those below the transformer. Go ahead and delete that up there and make some room. Or maybe I'll just move it out of the way. Move it out of the way for now. And I'll continue placing my attributes. I'll use the bottom rating attribute insertion point as the base point to give me my offset from the top of the geometry and move those over there. Move that. Looks like the only data shown on this 3-line schematic symbol for the transformer is the kV, class, and impedance, rating 2, rating 6, and rating 4 respectively. So I'll position those attributes to match what was shown on my 3-line diagram. I'm going to go into each one of these attributes and just delete the default values, but I want to keep the prompts. There they are. These attributes are going to be a different size, so I'm going to go back to the 3-line diagram quick and grab the text associated with the tag and description attribute and paste it into this drawing. Just do a Control-C, go into my new drawing, Control-V to paste. And then I'll just perform a simple match property to the tag and description attribute to get that size and space these out. That looks good. Just move these down a little bit. I can go ahead and remove this wire from the neutral to ground because that's actually going to be a wire in the schematic. Just move it up to that snap point there. Now I'll go over to the 1-line symbol and start grabbing connection point attributes. I'll grab both the X4 term 02 and the X1 term 02 connection point attributes. X4 denotes wiring that is coming into the symbol from the left side, and X1 denotes wiring that is coming into the symbol from the right side. X2 is wiring that's coming in from the top, and X8 is wiring that's coming into the symbol from the bottom. The trailing number of the connection point attribute will correspond with a term attribute. In other words, the X4 term 01 connection point attribute will correspond with the term 01 attribute. The term 02 attribute will correspond with the X4 term 02 attribute. When placing the connection point attributes for this symbol, I want to maintain the same term attribute and connection point attribute positioning as the 1-line transformer used to create the 3-line symbol. The reason being, when this symbol is complete, its symbol name will carry the same 5-character file name prefix as the 1-line symbol it's based on to denote a relationship and orientation between the two symbol types within our symbol library. I'll tweak my geometry here just a little bit, copy this over, just to close that gap between the connection point attribute and the winding. Alright, now I'll go over and grab the X2 term 07 attribute along with the term 07 attribute and place it at the neutral bushing terminal on the top side of the quadrant. There's going to be a wire that connects from the lower transformer winding to this terminal that is going to contain CTs. So I'll copy this connection point attribute up and place it on the lower winding. And then I'll rename that from X2 to X8 because wiring is going to come into this winding from below the connection point. Of course, I need to go grab the supporting attributes for the symbol from the one-line template and move them over. To maintain uniformity with this horizontal symbol, I'm going to go ahead and place those there, and then I'll just change the justification to middle center. Move that one over just a bit. The surf display is what's going to give me a value in the surf dialog box that'll help me distinguish between one-line and three-line symbols. So I'm going to give that a default of 3 equals 3L for 3-line. The 3 equals part is just what column in the surf dialog box that I want that value to appear in. I want to keep my WD jumpers and some of these other attributes the same, but one value I do want to change is the WD type attribute. For schematic symbols like this 3-line schematic symbol, the WD type attribute doesn't need to be there, or it needs to be blank if it's in the drawing, so I'm going to blank that out. Suppose I can clean up this drawing at this point. I want to just go and explode some of these blocks that were in the old AutoCAD block. And then purge the drawing out of any of this unnecessary stuff. Like so. The last thing I want to do here is to match up the connection point attributes with their respective term attributes. As I'm doing this, I'm starting to second guess the way I was approaching the build. This is a complicated block to build because there's more than one way to approach building a transformer symbol like this. My initial plan was to create this as a 3-line parent symbol and then create the bushings as secondary child symbols. The idea being that this would give me a little bit of flexibility in positioning the symbol on the bus, depending on how many CTs I have associated with it. But I think I'll include the windings into the parent symbol instead. I'm going to position these terminals with a 1/2-inch spacing. I'm almost positive the original drawing doesn't have this spacing. If I go back and I do a distance check just to verify, and I can really see that it's not. So we've standardized on a 1/2-inch horizontal bus spacing, so that's how I'm going to space these bushing terminals out. Again, grid spacing is something you don't have to use in this situation, but I personally do recommend it. And if you do end up using grid spacing, I would also recommend using the same grid snap settings between your schematic drawings as you do your symbol files. So I'm going to position these bushing terminals out about a 1/2-inch apart and reconfigure the device box. Now that the device box geometry is fixed and I've mirrored the bushing terminals over, I'm going to start placing more connection point attributes. The trick is I need AutoCAD Electrical wires to go from the windings to the bushing terminals so that I can place CTs and manipulate their position when the symbol is in the drawing. So I'm simply going to copy the X4 term attributes over to the left quadrant of the bushing terminals on the left side, and I'll go about renaming them with the correct term attribute numbers. And I'll go about doing the same thing for the right side. Copy that from the right quadrant to the left quadrant. And then rename the X1 to X4 on each one of these. So now when I insert this symbol, I'll have the wires break at the transformer windings, and they'll also break at the bushing terminals here. Same thing on the left side. Change the X4 to X1. And now I'll go ahead and grab these three term attributes, I'm just going to move those closer to the X term connection point attributes. And then select them, copy them over. And all I'm going to need to do is change the justification from middle left to middle right. Probably have to move them a little bit closer. Yep. And then change term 4 to term 04 to term 01, term 05 to term 02, and term 06 to term 03. I'm also going to get rid of the defaults here because that's information is going to be pulled in by the catalog when this symbol gets catalog information. And that's about it. What I need to do now is, after I make this little fix here, I'll go ahead and delete the rest of this template geometry, zoom to extents, and now I'm going to save the drawing. I think before I save the drawing, I'm just going to make sure that all of the default values in all of these attributes are deleted. Now I'll save the drawing. The symbol has a horizontal orientation, and it's a parent symbol, and it's part of the transformer family. So the symbol name is going to be H for horizontal orientation, XF for the family code, and 1 for the parent symbol. The extra 1, the 5th character, is something we always add to create a toggle function just in case we want to create a flipped version of this symbol. And I gave it transformer 2 as a unique identifier. So the last thing we're going to do here is I'm going to demonstrate how to create an icon for the symbol in the schematic icon menu. So I clicked on the icon menu wizard, and I went to my transformer folder. And so all I'm doing is I'm going to copy the icon for the one-line symbol, go ahead and save it, save as, to match my new block name, hxf11 underscore transformer 2 underscore 3 line or 3 dash. And then I'll just go about making the changes I need here to just give it a unique visual look so that the user knows what symbol they're going to be selecting when they click on this icon. So since it's a 3 line, instead of having the 2 terminals or the 1 terminal on each side, I'm going to make 3. And it's simple. Now I'm just going to save that, close down. So now, under the add drop down, I'm going to hit component. I'm going to give this icon a name. And under image file, I'm going to hit browse and go find the 3-line PNG file that I just created for the transformer. So that would be menus, images. This is where all your icons are stored for your icon menu. One thing is they have to be a PNG file. They can't be a bitmap. So I work with Microsoft Paint a lot to make these, and if I'm not careful, I'll save them as a bitmap and then I'll wonder where the heck they went. So I always remember to save them as a PNG file. So now that that's in, I'm just gonna click browse under the symbol and locate the symbol I just created. There it is. And one thing I want to do before I hit OK is I'm going to just delete this file path to just keep the block name there. So now it doesn't really matter as long as my environment file is pointing to my library files. This icon will always find that block. So now if I go to insert the symbol, go to 3-line, and there's the symbol. Ready for catalog information. This demonstration was an example of creating a fairly complex schematic symbol and then connecting it to the icon menu. As you can see, there's a lot to consider when building a good schematic symbol. It takes time to clean up the geometry and consider attribute placement. It's also worth considering whether a complex symbol you're wanting to create can be broken up into a parent-child relationship to give it more flexibility. Sometimes it's prudent, sometimes it's not. A key thing to remember when creating schematic symbols is to reuse attribute templates between common symbol types whenever possible. This applies to schematic, symbols, wiring diagram, and panel symbols. There are exceptions like tag 1, tag 2, p-tag, things like that, but copying and reusing description and rating attributes between symbols will speed up symbol creation as well as promote uniformity between symbol types of the same family, and it'll help your users know exactly where to put the data. Symbol creation is really a 4-step process, sometimes maybe even a 5-step process. This video covered steps 1 and 2. In the next video, we'll cover steps 3 and 4, entering the symbol information into the catalog database and footprint lookup file. Thanks for stopping in again. See you in August with more AutoCAD Electrical content here at the Empirical SD Learning Center.